Okay, welcome to Algebra 1, Semester 1, Unit 3 notes. This is our very first video of this unit. It's graphing linear equations using t-charts and slope-intercept. Okay, that's page 1 of the packet. Page 2 of the packet is your vocabulary, which you should know from the units previous, that I put these in order for you to study. So just list them A, B, C, D, straight down through. Put those on flashcards, put them on audio, put them on whatever you're finding is working best for you. You need to practice those about 15 minutes a day. Okay, in class, we will have a little ball drop activity that you'll do, and you'll fill these charts out on page 3. And we'll do a little bit of a lab, trying to figure some things out on that. Now let's go over to page 4. Page 4, from the activity that you've done in class, you'll be graphing the ball drop, ball rolls, that kind of thing. We'll talk about the difference between continuous and discrete graphs. Okay. Online. OL means online, so we need to do this part of this unit. Here's what I want to look at. We're going to talk a little bit about continuous and discrete graphs right now. If you are buying X boxes of cereal, will this be a discrete or a continuous graph? Well, here's what we look at. If we were to graph this, let's say the cereal is on sale. And let's say that it's $2 for a box of cereal. So let's put our dollars over here and our number of boxes here. So if we buy one box, how many dollars would we owe? Well, if you said $2, then you're correct, we'd owe $2. Now, let's say that they're not charging tax or anything in between. We're just going to pay this flat amount to whoever is selling the boxes of cereal. So if we buy 2 boxes, how many dollars do we owe? If you said $4, that's great, because we had said that it was $2 per box. So 2 boxes at $2 per box would be $4. Well, if we buy 3 boxes, how much would we owe? We would owe $6. Well, are we going to owe any amounts in between? Can we go in and buy 1.5 boxes of cereal? No. So when we graph this, we see independent points because we can't buy the in-between. We can't be charged with the in-between. So therefore, this is a discrete graph. The points are disconnected. Okay? Now, let's say, well, we want to save some money and we'll go buy cereal bulk. Well, if we buy cereal bulk, and this is just an extra, it's just a comparison for you. So if we buy cereal bulk and its cereal is $1.50 per pound, now we can buy in between because they can weigh it out, can't they? So we could buy 1.25 pounds or 1.5 pounds. So at $1.50 a pound, if we put it back up here on the graph, well, at 1 pound, the graph would go like this kind of. Because at different amounts, depending upon how many pounds were in a box, we would line up with the boxes, but in between we could buy pounds bulk. And so that would be a continuous graph because we would have the in-between. Okay, inventory of shoes. Well, let's say that that store has 100 shoes that are size 6. 200 at size 6.5 Are we going to have any points in between? Do we have sizes between 6 and 6.5? No, we don't. Now you might say, well, what if we had the numbers down here? We could have numbers in between. That's true, but we still have a discontinuation because we don't have the sizes between the 6 and the 6.5. So it's still a discrete function. Sales in a shoe store. Well, now here, as far as money, we can have all different prices, can't we? We could have shoes that are $5, some that might be $5.25, $20, $100, but there's no set amount, there's no separation in not being able to charge any amount between 0 and whatever your top dollar is. So this is continuous. Buying peaches by the pound, that would be like buying cereal by the pound. We could buy all the increments in between, so that would be continuous. Buying peaches by the peach, well, that means you can't go up and get a half of a peach or a quarter of a peach. It has to be a full peach, so that's a discrete. Go ahead and pause the video right now and do these others, and then I'll fill them in, and you can ask questions in class if you didn't get why they were filled in a certain way. Okay, next page. This is page 5. Graphing lines. When given relationship between two items, we can graph a line in a few different ways. Let's say we are told there is a solid trend in the price of gasoline increasing at a rate of $2 every 3 years. By graphing this, we can easily predict the price of gasoline in, say, 20 years. So, let's say 1 year after we're told this. Actually, our years go up by 3, so let's just go up by 3. At year 3, oh, I don't give you a starting price. Wonder what gasoline is worth about now. I think it's probably worth about $3 a gallon. So let's start at, let's call it today year 0. And we'll say it's $3 a gallon. In another year, or let's say in 3 years, because it fits our graph better, it would go up $2 more, so that would be $5. This is your dollars. This is your years. Trying to figure out what it would be in about 20 years. So in 6 years, would be $7 a gallon. In 9 years, $9 a gallon. Just keep adding 3 to this side and 2 to this side. 12 years, it's $11 a gallon. 15 years, it's $13 a gallon. In 18 years, it's $15 a gallon. Let's hope this doesn't really come true. In 21 years, it is $17 a gallon. Again, we were adding 3 to the years, 2 to the price, because it says it goes up $2 every 3 years. So now we come over and graph this. 0, 3 was our first point. So 0 on the x, up to 3 on the y. Now at 3, we say it's about 5. At 6 years, we say it's 7. At 9 years, it's 11. At 12 years, oh, I'm sorry. At 9 years, it was 9. At 12 years, it's 11. At 15 years, it was 13. At 18 years, it's 15. At 21 years, it is 17. So if we connect that, I don't have a ruler handy. I'll use the side of a stapler. You can use the side of your phone if you don't have a ruler. Something for a straight edge. If we connect that graph, now we can find our different predictions. And we ask, well, what's the predicted gasoline price in, say, 20 years? So we'd come across here to the years, we'd find 20. Well, here's 18. There must be 19 and 20 before 21. We come up where 20 is, and we see 20 would be right about here. Now we come over to the dollars, and we see about where that lines up. Well, we see 0 is lined up there, 2 is lined up there, 4 there, 6 there, 8 there, 10 there, 12 there, 14 there, 16 there, 18 should be up there. So we're saying that at 20 years, it's just over $16. Now, does that match up with our number and our sequence here? At 21 years, we have $17. So we could say it's between 16 and 17. $16.50 is an estimate. Okay? I want you to be able to plug numbers into a pattern, find the points, graph those points, and then make predictions off of that graph. Okay? So in class we'll be doing that. That's the end of this first segment of notes.